Good day, everyone. Thank you for joining today's webinar, The Business Value of Docker. A few housekeeping items before we get started. As a reminder, this session is being recorded, and a copy of the recording will be sent out a few days after the webinar. We will take questions at the end, so please post your questions in the Q&A window located in the lower right of your screen as they come up, and we will address them at the end of the session. I would like to introduce today's speaker, Jim Armstrong, Product Marketing at Docker. Jim, I will now turn things over to you.
All right, thank you very much. Get presentation going here. I want to thank everybody for joining us today. As Melanie said, my name is Jim Armstrong. I am in product marketing here at Docker. And today what I want to show you is some of the business benefits of Docker. Specifically some of the operational benefits that some of our customers have seen already with Docker, and specifically what some of the IT teams are seeing with Docker. You know, Docker has a great reputation, I think, on the developer side of the house, and it's still building that reputation with IT teams as they start to explore it a little bit more and get a better feel for Docker. So we're going to walk through some of the features of Docker and talk about how they relate to some of the things that IT teams do, and then show you kind of where some of these savings and business numbers come from as we walk through some of those things. You know, if you haven't heard of Docker before, which you probably all have, right? It's a software container. So essentially what we're doing is we're taking the applications that people run, and we sort of create this container around them such that we know exactly what's running, and we can do a lot of sharing in between different containers that are running similar components. And we'll get into some of those details here, but Docker has been around for several years. The concept of containers has been around for many years before that. But what Docker, the company and Docker, the open source containers has done is really popularized this notion and made it much simpler for people to use. More recently, what we're finding is that there are a lot of benefits to IT teams when they adopt Docker as well. And we've got some different tools and things that IT teams tend to use as opposed to what the developers tend to focus on. But those tools really fit together. So we'll take a little bit of a look at some of those things today as we go through the presentation here. But again, it really is a tool that's being used by both sides of the house. So developers, obviously, you know, they're out there, and most of them are already using containers of some sort, probably Docker containers. A lot of times it's the open source version of the software that they're using. It's free, it's cheap, it's very fast and easy. There's a huge community built around it, so they can go get the tools and application stacks that they want quite easily with Docker. We're also finding IT teams, as I said, that are starting to adopt Docker as well because there's a lot of benefits from them. Part of the reason IT teams are looking at Docker is because they do deal with a very diverse environment. So we have a lot of virtualized applications out there, but we still have a lot of bare metal applications that are there as well that, you know, quite frankly, I think a lot of people are sort of afraid to touch. They don't want to put it into a VM. They don't quite know what to do with it. We have a mix of applications running in private data centers and running out in the cloud somewhere. And then, of course, there's, you know, mixes of operating systems out there and all kinds of applications that have been around for many, many, many years, right? And some that are brand new and more what we would call cloud native or microservice type applications that are out there. And Docker is great at handling all of those. I think when people think of Docker, the tendency is to sort of equate it with microservices, with Linux, maybe in the cloud, maybe on premises, and probably more bare metal than anything else. But the reality is that it handles all of these different, you know, diverse environments equally well from the same set of tools. And that's one of the big, you know, powerful pieces of Docker is that it can work across such a diverse environment and help with all of these situations. If you've been in IT for any amount of time and you've talked to any number of software vendors, I'm sure you've seen numbers like this before, and you may have even your own numbers internally. But the point is, a lot of IT, a lot of the budget is spent on the maintenance of applications that already exist. And some of those applications have been around, like I said, for years and years. And, you know, there's a lot of effort put into just keeping the lights on for those applications. Now, there's a big effort, of course, to modernize those applications or to build brand new applications, to find new ways to reach customers and interact with those customers much faster, which for an IT person presents a challenge, right? Because those tend to be very different things from an operational perspective. The new applications are you know, much different animal than the you know, older applications that you've got. And again, I think that's where Docker plays very nicely, because we can actually help with both of those, right? You can take a legacy application, you can containerize it, and we'll take a look at that a little bit today. And you can start to derive benefits from it. And in a lot of cases, what customers are doing is they're taking some pieces of those applications and modernizing it as well. And then, of course, you can always build brand new applications with Docker as well. And from an IT perspective, you know, using Docker for both also makes it easier to maintain those applications long-term, and it makes it easier to roll out applications, whether they're new or whether it's just a new version of an existing application. And, you know, one of the unique things about Docker is that we do work across such a diverse you know, set of platforms and applications. So Linux and Windows, you know, we talked about already. Windows is you know, fairly new from a container perspective, but you know, if you're using Windows and you're using the containers that are built into Windows Server, those are Docker containers, and we work across both of those. We have people that actually use Docker on mainframes, and I laugh a little bit about that because you know, it's amazing, but they're still out there, and they're huge, right? And they just, you know, for all the talk of mainframes going away over the last 20 or 25 or 30 years, they haven't gone away, and we still need to do something with those applications. And of course, a lot of people going to the cloud now and getting rid of their own servers, and Docker works across all of those. As I said, it also works across, you know, new applications, old applications, all those sorts of things. There are a lot of other container technologies out there, and a lot of them use, you know, some of the open source Docker components for the container, but they have different, you know, management pieces and those sorts of things. What you'll find is there's a lot of sort of pieces, parts that might compete with the overall Docker product, but you know, most of them are focused on Linux applications only, where we are, you know, looking at Linux and Windows both. A lot of them are built into a developer platform, which you know, is going to cause you to actually have to make some code changes, or your developers maybe more likely to have to make some code changes to really adopt and use that container platform. And so with Docker, we don't require any of those things, right? You don't have to make any code changes. As an IT person, you don't need to know really all that much about the code at all to adopt Docker and to use it. Of course, your developers, you know, will have their own use cases for it as well. So as we look at Docker, and we look specifically at the enterprise edition of Docker and IT users who have adopted this, we found some pretty, you know, fantastic results with this. And we're going to walk through each of these, but we're finding that as people adopt Docker, number one, and maybe one of the biggest in terms of dollar savings, is just getting better server density. And again, it doesn't really make a difference whether you're virtualized or bare metal. We're finding some pretty dramatic results in both instances. One of the, I think, kind of the big myths about Docker is that it's either, you're going to either run Docker or you're going to run VMs, but you don't do both. And that's really not the case. Customers, in fact, do both, and we'll take a look at that a little bit. The other big piece of this is more operational, but it's the reduction of maintenance time. So, you know, when you have to go out and deploy new versions of your application, when security teams say, hey, there's a you know, major flaw in an application or a component of an application, we need to update that application across the you know, data center. Those are time-consuming tasks, and Docker makes it much easier. So we'll take a look at some of that as well. We find that it's easier just to deploy apps in the first place, right? So to get that initial application deployed, you know, go from the developer's desktop out to your production environment can become much, much faster. And then for the developers themselves, there's a lot of benefits too. And, you know, from an IT perspective, you know, it may not be your number one concern to think about the developers, but the fact that this is a tool that you could both use and sort of, you know, build this software factory that works across the board, I think is a pretty big benefit. And again, the other thing from an IT perspective is you really don't have to be, an expert in the code itself in order to adopt Docker and get these benefits. So we'll take a look at each of these. One of the big questions when they come up, you see numbers like 99% savings and those types of things, right, is, okay, Jim, you're in the marketing team. What dark crevice are you pulling these numbers from that you're putting on these reports, right? And there are several sources for these, for the numbers that we use for ROI. I'm going to show you at the end of this presentation today our online ROI calculator as well. And there's some calculations that take place there, obviously, and the assumptions for that all come from a lot of these public resources. So this is a survey that we did with our customers near the end of 2016. We went and asked them how they're using Docker, what are some of the changes they've seen after they started using Docker. The link for this is right at the bottom of the slide here. You'll have these slides, and so you can go through this whole report. But that's one of the sources that we get, and particularly what we're going to focus on today is some of the numbers in orange here, which I think are more on the IT and operational side of things. But again, a lot of great feedback and results from developers as well. And then with our customers too, we've got a lot of great stories. And most of these stories that you'll see today, if not all of these stories, in fact, are available on our website. So you can go and find like MetLife's story. There's some videos and case studies and things that go with it as well. And so I'll show you as we go through this presentation today and we kind of go through each of these sections, a customer story that kind of relates to that section. So you can actually see some actual customers who have seen some of these benefits. Obviously, your mileage may vary. You may be running in a highly virtualized environment that's super dense and super consolidated, in which case your infrastructure consolidation may not increase at all with Docker, right? But there are still other benefits that I think you'll find from that. And quite frankly, we're finding a lot of customers who, even though they're virtualized, do still gain some consolidation benefits when they add Docker to that environment as well. All right, so let's start to dive into some of these numbers here, and I'll show you a little bit about Docker. For some, this may be a bit of a refresher, on the Docker technology itself. If you're pretty familiar with Docker, you're going to recognize some of these pieces. But for some of you, this may be brand new. So I want to make sure you kind of understand how Docker works, so you can understand, where some of these benefits come from. So server density is an important one. As I said, it tends to be one of the big dollar savings because servers are expensive, and licensing and for everything else like that goes on top of the servers can be expensive as well. So if you think about how an application is sort of set up, right? You have your different layers. You have an OS layer. You have some application server components that sit on there. In this case, it's a Java application with a Tomcat Tomcat server and some other components on there. There's some custom code, obviously, that runs on top of this. From a container perspective, we have this writable layer that goes on top of it, and that's your basic container. If you just had one container, that's sort of how it would look. Each of these boxes that you're seeing here is a separate layer inside that container. So the OS, the Java layer, the Tomcat layer, Maven, your own code that goes in there. All those layers at the bottom are actually immutable. They're not changeable in the running container. So they stay static. The only thing that's actually changeable, the only layer that you can actually write on, is that last layer up at the very top of the container. So that's where anything that as the application runs, logs, those sorts of things that might get stored inside the actual container itself, those would all go into that writable layer. So this sort of everything below that writable layer is your image. And so these are the things, if you ever go out to Docker Store, or you may call it Docker Hub, you'll see tons and tons of images out there. This is essentially what's in there. Now, the images out on the Docker Store are not going to have your custom app code in there, although you could put your custom app code and then ship it out to the Docker Store if you choose to do so. We'll talk about some of those options here in just a second. But that's if you have one container. Now, if you just have one container, probably not a lot of benefits to that, maybe a few, but you really start to get some of the benefits and some of the savings from Docker when you have more than one container. So we have an exact copy of that second container. What actually happens is because we're aware of all these layers, we share them across the containers. So instead of having two individual, completely separate copies of Ubuntu, we just need one because both of those containers are running off of the same thing. Instead of two copies of Java, two copies of Tomcat, two copies of everything, we just have one copy of everything. And the only thing that's separated then is that writable layer on the very top of the container. And this is where we start to get a lot of benefits, right? Ubuntu, not a huge operating system, but it does take some space, right? And what a lot of people actually do in their containers is they'll come down to very, very small operating system images. On the Linux side, we have a version of Linux called Alpine that's only like 5 megabytes in size. That's it. That's the entire operating system, right? And then everything else you need for your application sits on top of that. But there are Windows, Windows layers as well. As we continue to sort of build out this example, let's put up a third container. This container will have a slightly different set of code in it. So again, because Docker's aware of what's in the container, we can actually separate those things. So as we build up, we notice that the first 3 layers are the same, so we'll share those across. That third container, because the Maven is a different version, we're going to have everything, from that layer on up separate, right? So those things are all going to be managed separately. And you can continue to sort of build this picture out, right? So we have a fourth container here that's running a completely different application on it, still running Ubuntu, so we can share that across the container. And then we have on the far right a couple of containers that are running Windows. And one small note here, and it's kind of an error on my part. I have the Docker engine looking like it's really spreading across all of these. In fact, what it should show is the Docker engine underneath the Linux and the Docker engine underneath the Windows. Those are two separate things today. They'll all be managed by the same tools, but in terms of, when you're actually deploying Docker, those would be two different engines that are doing that today. Just a minor change. It doesn't really affect, anything that we're going to talk about here today. But that's where we get some of the infrastructure savings, right? So we start to talk about consolidation. If you think about running VMs, for instance, what you end up with is, 4 copies of Ubuntu or 2 copies of Windows, and every VM has its own copy of the operating system, and that takes up a lot of space. Both disk space, memory for the running application, all those things are consumed because we have all these individual copies of it. And so that's where we start to see a lot of the benefits of running in containers is the fact that we can share across these things. And also because as we optimize those applications, we tend to make those layers smaller and smaller. So instead of running a full copy of Windows 2016, we'll run Windows 2016 Nano, much smaller, saves us space there as well. So those things are what lead to a lot of these infrastructure savings. And again, if I haven't said it enough, I just want to reiterate this one more time, right? The savings come whether you choose to run Docker on bare metal or you choose to run it with bare metal applications, or whether you choose to run Docker inside of VMs. Now, I will say on the VM side, we do see some differences in the way that it runs in VMs. So for instance, you'll see a little bit lower consolidation numbers in general. When people are running in a virtualized environment. You still have some overhead from the hypervisor. You have some overhead for each individual VM. The other change that we see people go through if they're running this in virtualized environments is instead of, on the left side here, we might have 8 different VMs. On the right side, if that was the same guest OS across all those, we might just have one big VM. And again, that would allow them to share that guest OS and share those layers. If they're in separate VMs, we can't really share those layers across that VM boundary. So some changes there in terms of how the VMs actually operate. But the point is, Docker and your virtual infrastructure, whatever the hypervisor is that you choose to use, will work just great together. And just to kind of show you, a company example of this, we have a large nutrition weight management company that has used Docker in their environment. Specifically, if you look at the infrastructure utilization for them, they went from, their application requiring 96 servers before they started with Docker, and they cut that down to 12. So they're actually one of those customers that's actually, well above the 50% decrease in terms of infrastructure that they're actually using with those applications. Again, your mileage is going to vary depending on how consolidated you are, But chances are, you know, what we're finding with a lot of customers is there's always some room for some consolidation there. Moving on to the next piece a little bit, this notion of reducing the maintenance time. And again, specifically what we're focusing on here is those applications that are already deployed and you have to go out and fix them for some reason, right? Maybe it's a code change. Maybe it's, you know, some security vulnerability in one of those, you know, application pieces. Whatever the case may be, there's always maintenance that has to be done to your existing applications. And Docker can help with that quite a bit as well. You know, kind of think about the traditional environment that a lot of customers have. Again, you have these VMs and everything is kind of separate, you know, across that environment. And really, from a virtual infrastructure perspective, you know, whatever your hypervisor is, it doesn't really tend to know a whole lot about the applications that are actually running inside of it. Maybe it knows the OS, but generally speaking, it doesn't know a whole lot about the application itself. And that's where I think Docker really sort of helps out quite a bit. You have the VMs that manages the hardware, Docker manages the application layer. But if you kind of think about what you would do to patch this, right? In our previous example, we have that one container, in this case it's a VM, that has a different version of Maven from its two peers that are over here on the left. And let's say, you know, just for example, that security finds that there's some big major problem in this particular version of Maven, and they need us to patch it, you know, rapidly and fix these things. Well, you know, there are probably a lot of patch steps that I've left out here, but a simple view of this, you know, you have to go, one, connect to that VM, you download the right version of Maven and get it installed. And, you know, hopefully they have some pretty decent instructions for that, or, you know, maybe the app team or the dev team writes up some instructions and maybe they do a good job, maybe they don't. You have to configure it. You know, if this is going to be a peer group, then all three peers really should be, you know, as identical as possible in terms of their configuration. The custom app code then has to be moved over. You have to make sure you're running the right version of the app code that goes with that version of the application stack. Obviously, again, once that's there, you have to make sure that everything is configured the same. And then, of course, rinse and repeat, right? Find everything else that happens to be running that version of Maven, and then, you know, patch it as well. And there are several of these steps. Now, you know, if you think about it, probably any of these steps could really be potentially a problem. But I think the ones that sort of trip up people the most are the ones that I've got here in yellow, right? You know, just the step of going through and sort of configuring it the same as all the other systems. A lot of times people will have a runbook for that, but the runbook is out of date, or somebody forgot a step, or, you know, they have the runbook for 339, but 350 has some slightly different steps in it. Those sorts of things, they're hard to maintain. There's other tools out there, right? People will adopt Puppet and Chef and these other things that kind of help with those things, or, you know, but again, those tools tend to get out of date as well and tend to be a little bit hard to keep up with. And so this is where Docker can really help with the maintenance of these applications, right? Essentially what we do with Docker, we go back to our other picture, right, where we're sharing layers here. We've got everything into containers now. And essentially all I have to do is declare that I should be using a different image. Remember, the image is everything from the custom app code on down. So just declare that this should be using a different image, and I reboot it. And when I reboot it, when it comes back up, it's running Maven 3.5, and it's running the right app code. And of course, because all these three containers are sharing the same image, they're all going to be configured the same. I don't have to go through and manually do any of those steps in order to make those configuration changes. So with Docker and with the tools that we have, we make it very easy to go through and actually maintain these applications. By the way, if you wanted to change the image itself, right, that's a pretty simple process to do. We'll show you a little bit about how that works. And at the end of today's presentation, there's pointers to several other webinars that we've done that go into some details on things like the layers themselves and management of these layers. So if you have questions about that, there's lots of resources we have for you. But that's how, you know, we would do maintenance in the Dockerized world, right? So to kind of give you sort of a better feel for this, we'll dig in just a tad bit deeper here and really show you kind of the IT side of things and the tools that you would use to kind of do this, right? And when I say you've got to declare that you use a different container, what does that really mean, right? So we talked about the layers and the images, and, you know, we've got a simplified view of our application environment down here on the bottom right. Really, the layers themselves are managed through this thing called a Docker file. It's a plain text file. You can go to Docker store, which is just store.docker.com. You can look at images, you can see Docker files, you can do a search for Docker files, and you can find tons of them. They're pretty simple to actually read. But again, you don't have to know a whole lot about them. You don't have to manually go through and create Docker files if you don't want to. But all the details that you might want are in there. The way this actually works, though, is once you've got those images, you store them somewhere, right? And we store them in what's called a registry. And I mentioned Docker Store. That's the public registry, right? There are sort of two really sort of main pieces to Docker Store, the public side. There's sort of the Docker maintained side, so the side we maintain from the corporate perspective where we know who the contributors are. So if it's Canonical contributing, Ubuntu images or Microsoft contributing, Windows images, we have that piece of it, and that's more along the thing that you see Docker certified here. You'll see that badge in a lot of places. There's also a community hub, right? And there are literally thousands and thousands of images that are out there that people have contributed, and you can go out and download those if you want to. But what we find with a lot of IT customers, they don't want to go out to the internet and download images all the time, right? You don't trust what's out there. You don't know who it came from. You want to build your own images. You want to have a private store of those. And it's equally important for the developers to be pulling from a secure source when they start developing your applications as well. So what you would really probably have in your environment is this thing called DTR, the Docker Trusted Registry. And you may have actually more than one of these in your environment. But that allows you to create your own private registry of images that you use just in your environment. So that custom app code layer that was on top of our containers there, we may not want to push that out to the internet, right? So we can store that in our Docker Trusted Registry. And we can store the base layers in our Docker Trusted Registry as well, so we know what's in there and we know exactly where it's coming from. And then from an IT perspective, the way that you control this is through another piece called the Universal Control Plane. So again, you don't have to mess around with the Docker files. You don't have to, mess around with a whole lot of the command line tools and things like that. You certainly can. I mean, nobody's going to stop you from that. But we have a nice, web front end that you can use to set access permissions. And, when I say declare what image is being used by a container, Universal Control Plane is where you can go to make those declarations and control this and actually do things like the application maintenance itself. I did mention as well, right, and I've said this before, we have, Docker working with both new applications, and some of the applications that I've used in my examples probably tend a little bit more towards the new applications. But if you go out to the Docker Store, you'll find lots of images that are out there that are for, what I would call probably legacy applications. There's images from Oracle that are out there. So you can go get Oracle 12c, the container for that. There's IBM DB2 out there. Lots of images from Microsoft and on and on and on, right? So really, truly, there are a lot of these traditional applications that have been containerized already, and you can go get those containers and start using them very quickly. Another piece that goes with this, right, and this is kind of tied in with that Docker Trusted Registry, is the ability to actually scan those images and know, number one, know what's inside the image. So we can look at these layers. The screenshot that you're seeing on the right is showing you the actual layer. So, that Docker file that I showed you, right, has each one of these commands, 1, 2, 3, 4, 5, 6, 7, 8, listed in the Docker file. And essentially what the scanner does is take apart each one of those layers and then scans the software that's there. So it'll tell you exactly what's inside the container, and it can also compare it against the CVE database. So we can actually tell you what vulnerabilities are out there that exist in your applications as well. So now you've got a trusted registry. You can scan what's in the trusted registry so you know what's there. You know ahead of time what vulnerabilities are there. You can either choose to patch them or, set up other tools, other protection systems, to block ports or whatever you might need to do to sort of protect yourself from some of these vulnerabilities. But it gives you this nice way of knowing exactly what's in the registry, exactly what the issues are with those things that might be in the registry, being able to go through and fix them, which all ties into that whole maintenance perspective, right? Part of it is going out and finding, like we said in our early example, everything that's running Maven 339. Well, that's not necessarily an easy thing to do. But because we know what's in those images, we can certainly help, with that side of the problem as well. Two things go hand in hand, really, to get us to this reduction in maintenance time, right? That the fact that this whole run book, the whole maintenance routine itself becomes much, much simpler. In a lot of cases, there may not really be a need for a sophisticated run book anymore. And then the fact that we also have these secure images. We know where they come from, we know what's in them, and we can, push those out with confidence. Leads to this reduction in maintenance time that we see in our results. Visa, a great example of this, right? So Visa is using Docker, and for them, the patching process, prior to using Docker was painful. It took, weeks, literally weeks, to push upgrades and patches out to their existing applications. With Docker, that whole process changes, right? Exactly what we showed you before. It becomes very simple for them to just declare that this container should be using this new image that's got the right, level of software in it. A simple reboot, and it's back up and running with the latest and greatest software. Moving on to the app deployment side of things. A lot of what we just talked about, so the Docker Trusted Registry and scanning those images, of course, that's going to help with application deployment as well. So there's a lot of benefits from that. But there's some additional pieces in there as well, right? Think about the actual creation of images. Somebody is going to have to do that inside your organization. Put the custom app code in there and all that sort of thing, and sort of populate your trusted registry for you. You need controls over that, right? Who can contribute, who can pull from the registry and make updates to existing images, those types of things, right? So you need that level of control. You need a way of sort of saying, here's how we're going to gate the code, the application as it goes from the developer's laptop all the way through to the production systems and how that's going to happen. And then, of course, the application itself. Most applications don't exist in a single VM or a single container. There's multiple systems that have to work together, and applications themselves have to talk to probably other applications and databases. And so all that architecture has to be defined as well. It's not as simple as just having one image. You really need to sort of define what the application itself looks like. And of course, we can help with all of those things with the universal control plane, with the trusted registry, and with some other pieces. So let's talk about those a little bit here, right? Talked about the fact that on the Docker store, we can certify those images. We can tell you they came from Canonical, or they came from Microsoft, or they came from Oracle. So you know that they came from a trusted source, you know what's in them, and you can pull them down and use them with confidence. But internally, you probably want something like that as well, right? You want to know that the images that are going into the registry came from a specific group that's allowed to put those images into the registry, and that you actually can trust those images and move them on up the chain into production. That's all part of this notion of having a secure software supply chain. And so working hand in hand with the security scanning that we talked about before is another Docker service called the Docker Notary. Docker Notary allows you to do is verify the actual images. Who did they come from? Do we trust that person or that organization? And can we use those images in production or only on development boxes? Those types of things, right? All of that is part of this, can be enabled by using this notary service. So it's a simple way of verifying who the images came from and whether or not we trust them and where we trust those images to run. So again, as you sort of think about the application, right, all these different layers that we had in our example, we have Ubuntu. We can scan that, find all the vulnerabilities in it. We can sign it so that we know exactly where it came from and say that we trust this version, and that can go into our trusted registry. Then layer Java on top of it, go through the same process. We trust it, we've scanned it, that can be in our registry, on and on and on, right? So we have these images, we know exactly what's there. We can set permissions that tell our developer team, you know, these are the images that you're allowed to use because they're the ones that we trust, and they're images that we can actually promote into production, right? So that question around who and what comes from the notary and from the security scanning of these images. Now, all that again is controlled by UCP. So we're not going to walk through all these, buttons and panels here, but UCP is where you would control this. You would define things like services in UCP. And the services would be the actual containers themselves. You can see here we could have one or more replicas. In our example, we had three replicas of that first container. You can define all of that here. Things like networks, we talked about the application architecture, right? You can define the networks here. How do those different containers talk to each other? What are they allowed to send back and forth, or what are they not allowed to send back and forth? Or, you know, public access as well, right? External access to the application, what's allowed in and out. Volumes, so we talked about storage within the container. Sometimes you need storage outside the container. Sometimes you want to have a permanent data store, and maybe that resides somewhere else separate from the container. Maybe it sits on an array, or it sits on you know, some other virtualized storage environment. We have volumes for that. We won't go into all of these because, you know, each one of these topics, networks and volumes and some of these things, can take up an hour or more in and of themselves. And you see at the end is some links where you can drill into these. But what I want you to take away from today is in UCP, define all these things. So the architecture is defined here. The images are, you know, where do they come from? That's defined here. All these controls that we have over the application that we need to get that application and roll it out into production is all defined here in UCP. A little bit more detailed view here, so you can see, you know, again, kind of some permissions. You can see where we define an image that's going to be used here. On the right side, you see things like how we would do an update. Parallelism, you know, I might want to do just one container at a time. I had 3 there, maybe I have 100 of the same container. Do I want to do 10 at a time? Do I want to do 5 at a time? All those types of controls are all defined here. All the permissions that you need over who can run these updates and all that sort of stuff is all defined in UCP. So now we've added this ability to verify the images and know that we trust them. We've got our secure components here, right? All of these things, of course, add up to faster deployments, right? We can very quickly verify, you know, where the applications are coming from. We can even automate a lot of this, right? Now that we know where applications are coming from, we know who to trust, when to trust them, and we can, you know, set security policies through UCP, right? Those lead to much faster application deployments for our customers. And by the way, one thing that we've talked about a lot here, I think, is the on-prem deployments. And I said this kind of at the beginning, but just to reiterate, this works in the cloud as well. So it's not just for on-prem deployments. We have a lot of customers who are moving their applications to the cloud, or they already have some applications in the cloud that are running in Docker containers, and you can use all of these tools. You can have a trusted registry, you can have, you know, notary signed images and security scanned images and things. The trusted registry could sit on-prem and your applications may sit in the cloud, or vice versa. Any combination of things is possible there. And we certify both the on-prem and cloud infrastructures to work with Docker as well. All right, so another example, another great customer example of this, right? For them, they went, you know, from needing, 5 hours before, from the time that it was committed, from the time the developer actually pushed the button to commit the code changes to getting it deployed, from 5 hours down to 5 minutes. So 5 hours really isn't all that long either, but 5 minutes obviously is much faster. So they're seeing some great results in terms of their deployment improvements. You also notice here deployment frequency going up by quite a bit. I'm going to talk about that here in just a second a little bit more, but we see that a lot with customers too. They can actually deploy more often. So they can do smaller changes and do more frequent changes and move those into production as well, much faster. So the final thing I want to touch on is developer productivity. Again, a lot of what we've talked about obviously has an application for developers as well, right? For them to be able to have the supply chain and be able to get things very quickly that they've done up into production is an improvement in and of itself. There's some other things that are a little bit more specific to developers. One is the whole notion of developer onboarding. Developers move amongst teams. There's always new developers that are coming into the environment. And for them, they need to be able to start coding as quickly as possible. And we find some pretty nice improvements with Docker on that side as well. And it's one of the reasons I think developers really started using Docker. There's lots of reasons probably, but this is one of the great ones, is the fact that if I join a new development team, it's very easy for me. I go to our trusted registry and I pull down the image that everybody else on the development team is using. That way I know I'm coding to the same thing that everybody else is coding to. And it takes me literally minutes to get Docker set up and pull down that image, and I can start coding right away. So that's huge. In fact, what we find with a lot of customers, I mentioned a little bit earlier, that you can actually have multiple trusted registries. What we find in some customers is they'll have a trusted registry that's for the developers and then one that's for production. And those two registries are linked, obviously. So developers work, they can push things back up into their registry. It can be promoted from one to the other. There's lots of use cases for that registry. But this is a great, great benefit to developers, just being able to start faster, right, and develop in a consistent environment, and an environment that looks like the production environment without having to set up multiple servers and things like that in order to actually get there, right? The other big thing that this solves is this whole notion, the whole sort of concept of it worked on my machine, which is a very common thing, right? For a developer to be coding away on their laptop, then they send that off to off to test or certification and find that it didn't work exactly the same because somebody forgot to, install the right libraries or, whatever the case may be. Again, kind of thinking back to that whole runbook thing, the environment wasn't set up exactly the same. Well, the containerization of the environment takes that out of the equation, right? It makes it so much simpler because you are developing on a system and containers in an architecture that looks exactly like what it's going to look like in production. So all of these things together help us derive the productivity increase for our developers, right? Getting them up to speed fast, and then having this nice, secure supply chain that helps automate the process of rolling out applications as well is another huge benefit to the developer team. Cornell University, a great example of this. So they have, obviously being a university, they have multiple campuses, multiple departments, and before Docker, they really didn't work very closely together. Each department kind of did their own thing and completely separately. And, people moving amongst those departments or new people that started working for Cornell, of course, had to go out and figure out exactly what the rest of the team was doing and manually recreate that environment. So the ability to bring, folks on board much, much faster with Docker was great. But what they've also found that's been a great, benefit to them is the increased collaboration. Just the fact that across campus now, more people are using Docker enables them to actually work closer together. So now they're able to tie more of their applications together. They're able to collaborate on the application stacks and things like that. So there's a lot of sort of ancillary benefits that are a little bit harder to measure, but have been a definite benefit to Cornell as well. So those are the big levers. What I want to show you now is the actual ROI calculator. So you can actually calculate some of these numbers yourself because, as I said, your mileage is going to vary when you're doing your own projects, and you should be able to calculate what this, what this might look like before you try Docker, and as you use Docker, you can actually come back and recalculate your numbers to see kind of how you're doing. So I want to show you the tool. It's available online if you go to docker.com. This top little sliding panel, the second one over, has the ROI calculator, or if you can remember it, it's just docker.com/ROI calculator, and you can go directly here. And this will allow you, with just a few simple inputs to actually calculate your potential ROI. So you obviously start with the number of applications that you might want to containerize, right? And, I'm going to change some of these numbers just to calculate calculate a little bit here. So I'm going to start with just 3 apps. It's not uncommon, right, for customers when they're first starting with Docker to have just a handful of apps that they're considering as candidates. How often do you actually go through a software release, push out an application in your environment? I'll leave that at 1 here. And it asks you for the number of servers that it runs on. Notice that you can use either bare metal servers or virtual machines. I'm just going to say it's an average of 4 per application. So we had 3 apps, that's 12 servers that it runs on. I'll leave these virtual. Again, I kind of hinted at this a little bit earlier, but there's a difference between bare metal and virtual in terms of what we see from customer results. Tends to be greater consolidation on the bare metal side. Again, we don't have some of the hypervisor overhead, but by and large, a lot of our customers, in particular, those that are new to Docker, are using this with their hypervisor platform of choice, and it works great that way. So I'm going to leave this at virtual machines. You can indicate whether you want to move any of these to the cloud or not. That's completely up to you. I'm going to just leave this at 40%. How many developers are actually supporting those applications? So I had 3 applications up there. Let's just say there's 5 developers per application. That puts us at 15. How long does it take a new developer joining that team to actually, become productive, to get the environment, to understand it, to start working and actually doing some code? I'll leave that at 40 hours. That's about a week, right? And then these are more of the IT sort of numbers, the last 2. So how many hours per week you spend? You notice here it says hours per dev. It's a little bit of a typo we're getting fixed. It should say hours per application. So how many hours do you spend on each of those applications per month, just in maintenance, updates and upgrades and patches and all those sorts of things? Everything from maintaining the operating system through maintaining the actual application itself. And then how long does it take you to actually deploy an application in your environment? I'll change this to 24, right, say 3 days. And then you can click the Calculate Savings button here. Now, before I do that, you may have some questions about how these numbers are calculated, right? And what are the default assumptions that we're making behind the scenes. You can, in fact, go through a deeper analysis if you want to, and we can customize a lot of those default assumptions. If you click this button, it'll take you to a place where you can do that. But I'll show you what the results look like here. So it'll do a 3-year analysis and give you the total dollar savings. Up here at the top, you'll notice that there's a download button. Over here on the right, you can adjust those inputs that you added, but it breaks it down into 3 big buckets. So the infrastructure optimization is here, developer productivity savings are here, and IT operational savings are in here as well. So you can look at each of those buckets individually. You can read a little bit about what some of the default assumptions are here. Again, if you want to change these, we'd be more than happy to go through a more customized version of this with you. But you can, of course, save this report as well and download it here. And again, if you want to call us and go through a customized version, there's buttons on the page to do that as well. But you'll get this nice report. You can download it, get a PDF so that you can share it with others if you want to do that too. But I wanted you to see that and know where this tool is, be able to go through it on your own. It's a very simple tool, as I said before. I also wanted you to see where some of these numbers come from, because some of these numbers can be pretty dramatic, right? And I wanted you to see that there are actual customers who are getting these pretty dramatic results. So it's not just numbers that we made up here. These are coming from actual customer deployments. All right. So as I wrap up here, like I said before, there are a lot of resources, a lot of things that we touched on here. We went through a lot of Docker concepts at a very high level, and you may have some questions about some of those things. There's lots of resources here that you can click through. Again, you'll have access to the slides and to the recorded version of this presentation so that you can, you can go through these resources. We do have a Docker page specifically for IT practitioners that you can go to. There's a lot of good resources there. A lot of these are actually listed on that page. So if you go to docker.com/ITPro, you can actually find a lot of these links, right now if you want to. You can sign up for a newsletter. We're going to have regular updates here. We're going to do more webinars like this in the future as well. And of course, we invite you to come see us live. We're going to be at several of the big trade shows that are coming up. So we'll be at Gartner Catalyst. We'll be at VMworld. We're going to be at the Microsoft Ignite show. And of course, we have our own DockerCon over in Europe coming up at the end of October as well. But that's it for me. So what I'm going to do is look and see if we have any questions in the chat window.
Yeah, Jim, there was a couple of questions. There are a couple of questions in the Q&A chat window.
Okay.
I assign them over to you. Let me know if you see them. If not, I can just go ahead and read them off.
Yes, no, I see a couple. Let's make sure I can kind of get through them. So there was one question here: is it possible to deploy the Windows containers on top of native host if it's Linux? And so essentially what they're talking about is, if I kind of, I'll hop back to the original sort of picture here real quick, just so you can kind of see it graphically. Right, we have this kind of image, right? So the question is, can I deploy the Windows containers on top of a native Linux OS? And I suppose, there'd be a lot of questions vice versa. Can I deploy Linux on top of Windows? The first answer is no. You can't deploy Windows on top of Linux. So that's where you would have 2 different Docker engines at the bottom here, and I kind of called that out as an error in this slide. You should see 2 different Docker engines, one on the Linux side, so everything that's in the orange for Ubuntu and one for Windows, so a separate image there. One thing that's a little bit interesting here is that Microsoft has announced, it's not, I don't think it's publicly released yet, but Microsoft has announced that Windows will be able to run Linux containers. And essentially the way they're doing that is they're creating an isolated Hyper-V VM that's Linux-based so that you can run the containers on top of it. So you would be able to run both. In that instance, it'd still be two separate engines though, really, right? You have Linux running as sort of its separate little engine in an isolated VM, and then Windows would be running its engine kind of separately. And again, you could do the same with VMs too, right? If you were in a virtualized environment, you might have one VM here that's for all your Linux stuff and one VM that's for all your Windows stuff, and then you would have the engines inside of there. So hopefully that answers that question. Let me go back to the Q&A panel here. How to isolate between the two containers? That's a great question. So essentially, the containers are actually isolated at that writable layer. So there's a couple different, I think, pieces that you could mean by isolation as well, right? So from the application standpoint, the actual stuff inside the container, right? They're isolated at the layers that are different. So if you look at this picture again, right, where we have Maven 3.5 and Maven 3.3.9, those are essentially isolated, but that's a little bit different. The actual isolation from the application perspective is really at this writable layer. So even though, in the next diagram we had all these containers, all three of these containers on the exact same thing, this writable layer is still different between them. And so that's one form of isolation. Anything that happens in this container on the far left is only going to affect within that container on the far left. And if something goes wrong, let's say it's I'll use virus as just a really simple example. Some reason let's use a Windows container. It's a little more common there. Sorry, Microsoft. But if this container gets a virus, right? Because it's coming from an image, I can reboot this container. The only thing that the virus affects is this writable layer. It doesn't affect any of these layers underneath it. And so if I reboot this image, I get a fresh image, a fresh writable layer, and the virus is gone, right? So that's kind of how isolation happens. That's from an application standpoint. The other layer of isolation would be on the networking side, right? So are these containers allowed to actually talk to each other? We have three containers that are sharing an operating system layer, but can they actually talk to each other on the network? And that's a different thing, and that can all be configured in UCP. So I'm not going to go into a lot of details because that's another longer discussion, but the short answer is yes. And the really short answer is, by default, they're isolated. If you want them to communicate with each other, you have to explicitly sort of state, here's what they're allowed to do back and forth, or if you want them to communicate externally, you have to set up policies that do that as well. And obviously there's a lot more detail to how that works, but load balancing across those sorts of things, all those sorts of things can go into it as well, and there's a lot of controls for that built into Docker. There's a lot of third parties that add network drivers and their own, like F5 has a container that has their virtual network capabilities in it as well.
And Jim, I think we have time for just about one more question if you wanted to pick one from the Q&A.
Yeah, so let me pick one here. So there's the next question I see. Does the case for modernizing traditional apps, does that mean rewriting the application or just taking the application as it is and containerizing it? So it means a little bit of both. What most people do is they just take the application as is and containerize it. And there's a follow-on question here that kind of asks, if you just did that, would that really help you keep your containers small? The short answer to that is it can actually. So think about the Windows containers over here on the right. You may be running on Windows Core, which is slightly bigger than Nano, not as big as the full Windows Server installation, right? But running on Windows Core across your applications. By containerizing them, because they're using Windows Core, you can immediately have that as some consolidation savings, right? Assuming that they're inside the same VM and they can actually share that layer. So you can immediately get some benefits without doing anything to the actual application itself. You don't change from a container perspective, it still thinks it's running on Windows Core. In fact, it is still running on Windows Core. It doesn't make any difference there. But from an infrastructure perspective, there's really just one copy of Windows Core there, and they happen to be sharing it. So you can immediately get some benefits, but you don't have to change any of the code. You don't have to change the application itself. And that's where a lot of our customers actually get started. When we talk about modernizing traditional apps, they're taking applications like this and not changing the code, but containerizing it. And then what they'll do later is they'll take that and say, okay, we don't really need all of Windows Core. We can make this smaller by going down to Windows Nano instead. And that helps them get smaller. And then they'll start to look at the .NET layer and say, okay, we can optimize this and take out some libraries that we don't really use in our application. And so over time, they'll look at this and they'll look at the code and they'll start to optimize it more and more. And sometimes people, if they really have control of the application, will then start to split out into separate services so they get even smaller containers and so on and so forth. But that's longer term, right? You don't have to do any of that, to get started and immediately start recognizing those benefits. So I think that's all we have time for on the questions. There's several others that are here. So here's what we'll do. We will take these questions. We're going to post a blog post that will go out on the public Docker website, and we'll answer some of the remaining questions that are here. And you're more than welcome to reach out to me as well. Again, it's jim.armstrong@docker.com is my email. It's jim.armstrong on Slack. If you use Slack, there's a community Docker community that you can go to. I'm jim.armstrong there. You can find me on Twitter as well. So I welcome you to reach out to me directly, but we'll answer these questions in a blog post as well.
Thank you very much, Jim, and thank you, everyone, for the great questions, and thank you for joining us today. This does conclude the webinar. Just a reminder that this session was recorded, and a copy will be sent out to you in the next few days. And also, please be sure to register for upcoming Docker webinars at docker.com/webinars, and also check out docker.com/events. We thank you again for joining us and wish you a great day. Thank you, everyone.